been made.
In this problem, it gives us a ton of information and, unfortunately, nowhere to do the math. So without a scratch piece of paper or some sort of writing surface, in the previous examples, we had a deal that looked similar to this where we could write it out. This is the absolute worst way to do math. On paper, in straight lines, that's the way to do it. But we're not given that. This is what we have. So in class, I would write this on the board or use the overhead. For right now, I'm recording it without that, so I have to make a place to put this information because the first thing I have to do is write her expression. So I've highlighted the information. Bridget went fishing with her dad and caught the first fish of the day. So F. Let me increase the font size. F. It weighed F ounces. So F is fish ounces. That's the variable we're going with. She caught four more. So we've got plus 4. Oops. Plus 4. Sorry, I misspoke. So let me back up. We have no place to do this work. So I have to do the work off to the side. I was trying to do 2 different tabs and that wasn't working. Here we go. So we have F ounces. It's not letting me type in the text box. Okay. Okay. F is for the first fish. She caught 4 more fish. The first one that she caught, the second one was 2 times the weight of the first fish. So plus, and I know this is probably super small. Let me try to do that. So F plus, what is it? 2 times the weight of the first fish. So that's 2F, not 2 F's, but 2F. And then she caught another one was 2 more than 3 times the weight of the first fish. So she caught another one was 2 more than 3 times the weight of the first fish. Whew. So what that means is the next one she caught plus was 3 times F plus, dang it, Bobby, plus 2. 3 times the first fish and 2 more. So 2 more than 3 times the first fish. Yeah. Get that. Okay. Plus, the next one was half the weight of the first fish. So 1/2 F. And the last one was 3/5 the weight of the first fish. So plus, dang it, Bobby, plus 3/5 not 2/5, 3/5 the weight of the first fish. So this expression is all to explain how many ounces of total fish that Bridget caught. That's Bridget's. So Bridget's ounces. Ounces of fish. Bridget's ounces of fish. Bam. That's her expression right there. Okay, next we need to make the expression for the weight of fish in ounces that Bridget's dad caught. So dad's ounces of fish, we need to, and I went through and I highlighted as best I could the parts of the equation that were, the parts of the word problem that we're pulling out to go into the expression. So we've got, the first one is 2 more than 3 times the weight of the first fish. So we say that it is 3F plus 2. All right. Again, that's, let me zoom in. Oops, out one more. Hi! I don't know why my video's on here, but let's get rid of that. Boop. Okay, so 2 more than 3 times the weight of the first fish. 2 more than 3 times the weight of the first fish. F. Okay. Plus one fish weighed 4/5 the weight of the first fish caught that day. So 4/5 F plus a fish that weighed 4 more than 2 times the weight of the first fish. So 2 times the weight of the first fish plus 4 more. Okay, so 2 times, 2 times, 2 times, and 4 more, and 4 more. So it's 4 more than 2 times the weight of the first fish. And the last was half the weight of the first fish that was caught that day. Whew, plus half F. Okay, so dad's ounces of fish were 3F plus 2 plus 4/5 F plus 2 times F plus 4 plus half F. All right, sounds good. So if all the fish Bridget caught have the same total weight as all the fish her dad caught, okay, so the same total weight, Bridget and dad. So now I know that this equals this, all the weight that Bridget got and all the weight dad's got are the same. I now have an equation. Okay, so these are equal. Then the first fish Bridget caught weighed blank ounces and the first fish her dad caught weighed blank ounces. So now I have to solve this. The first step in solving it is getting all the like terms on the right side. So all the F's on one side and all the numbers on the other. That's going to be really challenging on this workspace here, but let's see what we can do. Okay, I'm going to try to do this again. No, that's not it. Where did my other tab go? Dang it. Pause it again. Once I had the expression all written out on the blank spot that I could do the work from, I mean, I'm using a self-evaluation from a different page in order to do this, but after we have the first expression and the second expression, number of ounces Bridget caught, number of ounces Dad caught. Now I'm simplifying this out a little bit. So the way I did that was I looked at the terms that are similar and put them together. So one fish, red fish, two fish, two fish. So this would be red, and this would be red, and this would be red, and this is red, and this is red. See? 1, 2, 3, half, 3/5. Everywhere there's a space, or sorry, a number right next to the letter, a number right next to the letter, a number, even if it is a fraction, right next to the letter, and a number, it's not this alone +2 number. We can put those together and make 1 + 2 + 3 + half + 3/5 multiplied by F +2. The +2 and the +2. So that's how we simplified that. And we're going to do the same thing to this side. Okay, so we have 3 4/5 plus 2F. I may have made a mistake. One moment. 3 4/5 plus 2 plus half F plus 6. Okay. Sorry, I got my numbers messed up here. Let me back up. So we have 3F. We have 4/5 F. We have 2 F's and half an F. Then we have +2 +4. 2 + 4 is 6. So Bridget's simplified, Dad's simplified. Now we have to just solve this out a little bit, solve this out a little bit to get it more usable or simplified. All right, so once we have 1 + 2 + 3 plus half plus 3/5 multiplied by F plus 2 and equals 3 + 4/5 plus 2 plus half multiplied by F plus 6, then we break it down. So 1 + 2 + 3 equals 6. Half plus 3/5. Half plus 3/5 equals 1 1/10. So we have 6 plus 1 and 1/10. We would take that and look at 6 plus 1 is 7, right? And I'm keeping it color coded here. Well, I'm trying to keep it color coded. Plus 1 1/10. 1/10. Okay, so then it just keeps getting simpler and simpler. All we're doing is putting things together, adding them together, doing the fractions math. I used the fraction calculator to get these terms, and that's all we're doing. And then trying to keep it color coded so that way you can see the terms that are, uh, like I said, alike, if you will. And so you can see where those numbers came from. So that's all we're doing, was just keep doing that. Okay, so we've taken our 6th and 1 and 1/10, and we've combined it to make 7 and 1/10 multiplied by f plus 2 equals. We've taken our 5 and 1/3 and combined that to be 6 and 3/10 multiplied by f plus 6. So now our goal is to get the f's all together and on one side. And so in order to do that, I'm going to make this a improper fraction so that way it matches with this as an improper fraction, and it makes it a little bit easier to do the math in the next step. All right. So we went from 71/10, and over here we had 63/10. Remember, to get rid of, to undo, we had to we want the variables all on one side. So to undo this, we subtract 63/10 f, oops, f, make that black just for giggles. Okay, oops, I didn't make it black for giggles. All right, so we're going to undo this from this side and bring it over here. So now we've undone this. This side is gone. This 60, dang it. This 63/10 is undone. It's not on this side anymore. So on this side, we are left with this plus 6, which I will bring down and put right here. Plus 6. Okay. So once we take 63/10 away from 71/10, 71 minus 63 is 8. 63/10 subtracted from 71/10 is 8/10. 71 minus 63 equals 8. Then we reduce that down to 4/5. It's simple, divide it by 2. 8/10 is the same as 4/5. So now we have 4/5 F plus 2. Change that to black for continuity. Change this to blue for continuity. And change that to black just for giggles. Okay, so now we have 4/5 F plus 2 equals 6. Okay, see this plus sign? That's just a carryover. It's a given. I could delete it. I could get rid of it, but we're going to leave it there just so you know it's a positive 6. So now we have 4/5 F plus 2 on this side of the equation and plus 6 on this side of the equation. So in order to get rid of this plus 2, I need to subtract 2. Now I've gotten rid of this plus 2 by subtracting 2. What I do to one side, I gotta do to the other. 2. I'm gonna keep it nice and as organized as I can. I don't know why I copied a black deal and it made it red. Oh well. So you hopefully won't ever have to do this complicated on here. Get scratch paper, use scratch paper, keep everything in a nice neat line as best you can. All right, so then you are left with 4/5. Oh man, and it's blue. Let's change that to red. Again, just for continuity. F. I don't know why I do this to myself. Oops, I went too far up. Okay, so 4/5 F equals what's 6 subtract 2 is 4. We can make that blue just for giggles. At least we're having fun giggling and stuff. So now we have 4/5 F equals 4. Whew. So if you remember earlier when I confused us, we are multiplying the reciprocal to undo this, which means down here, I'm going to multiply by 5/4, and that's going to be red, and hopefully my dog barking doesn't interrupt my flow here. So that's going to be red, right? And then we've got the F. Let's see if we copy it down and see if it, nope, it's going to make it red. All right, so we got to multiply. This is multiply here. Multiply. Dang it. Multiply. Undo it. I did the math on the other one and showed you how to do it. I'm not going to go through that again, but if you need help on it, ask me. I'll screw you up and then we'll hopefully figure it out. But okay, so then on this side of the equal sign, we have 4 multiplied by 5/4. Make that blue, but it doesn't really matter. Okay, so now 4 times 5/4. 4 times 5/4. I think I can figure that out, but just in case, let's do this. 4 over 1 multiplied by 5 over 4, calculate, equals 5. Whew. So, by itself, the first F equals 5 ounces. Wow. So, Bridget's first F, Bridget's first fish, her first fish equals 5 ounces. Okay. The key to this is on your paper, you want to be very precise. If you remember in one of the learning goals, what you will be able to do, it's practice precision. So even on this, I kind of get my equal signs start getting thrown off. The more that we can keep this straight up and down, the better you're going to be. It's just about keeping it clean and organized. Okay? That's going to help you in the long run. I don't expect color coding or anything like that. I just did that so you could see, because it gets really jumbled really fast. All right, so now we know that she has 5 ounces for her first fish. So going back to the problem, if all the fish Bridget caught have the same total weight as all the fish her dad caught, then the first fish Bridget caught weighed 5 ounces. And the first fish her dad caught weighed how many ounces? Okay, now we have to go back. My course session is no longer valid. Okay, I'm back. Whew. So her first fish, Bridget's first fish caught, weighed 5 ounces. We figured that out through doing all of that work. So where Bridget's fish equals 5 ounces, we substitute into. So now it wants us to figure out her first, how many, the ounces of dad's fish, the first fish her dad caught, in ounces. Now, I don't know if you remember, but Bridget's dad caught 4 fish. The first fish he caught weighed 2 more than 3 times the weight of the first fish Bridget caught that day. 2 more than 3/5 the fish, 3 more. Let me back up. The dad's fish was 2 more than 3 times her first fish. So if we substitute the 5 in for her first fish, we've got 5 here. 3 times 5 plus 2 equals 15 plus 2. So we got this multiplication, all right? So 15 plus 2 equals 17. All right. Whew. So the first fish Bridget's dad caught weighed 17 ounces. Let's put that in and see if we're correct. Holy cow, that was a ton of work. Yay, we got it correct. Look, they make it look all easy. They got all that mumbo jumbo spread out. Da 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 da. Bam, bam, bam. Bam. And they expected us to do this without any worksheet area. So get yourself some pen and paper, come by, pick it up from the classroom, whatever you got to do, or open up something and do your best. But that's how you do it. That's how you solve that. Whew.
Combining like terms. In a single variable equation, there are terms with a variable and terms without a variable. We refer to these two sets of terms as like terms. The table contains examples of like terms. To solve a linear equation, we need to combine the like terms. Earlier, we applied opposite operations and the associative and commutative properties to group like terms. Then we applied the distributive property to combine them. We call this process of working with linear equations combining like terms. To solve a linear equation, we need to combine the like terms. Earlier, we applied opposite operations and the associative and commutative properties to group like terms. Then we applied the distributive property to combine them. We call this process of working with linear equations combining like terms.
Remember, if you need to know what these properties are called, we did look them up in previous lessons, but you can go to the dictionary and look them up. Okay, so producing the same mathematical value no matter how an expression's elements are grouped, so long as the order of those elements is the same. Okay. Or commutative. And we did put these in our notes in an earlier lesson, but those notes don't save. So that's not very helpful. So having or being the property of giving the same mathematical result no matter in which order two numbers are used with an operation. And distributive. So having or being a property of giving the same mathematical result when an operation is carried out on a whole expression and when it's carried out on each part of an expression with the results then collected together. So whether it's 3x plus 2x or 3 times 2 plus 3. Or something to that effect. I hope that didn't confuse you. Okay, continuing on.
Let's combine like terms in an expression. 3x minus 2 plus 4x plus 7. The terms 3x and 4x are like terms, and so are the terms negative 2 and 7. The like terms are highlighted in this expression.
So remember how I was highlighting and moving things around? That's what they're doing here. They're highlighting the like terms. 3x plus 4x are like terms. So they switched them by applying the commutative property. So, 3x and 4x. Let me see here. 4x. Bam. 3x and 4x are like terms. Oh, darn. Let's do it blue. Remove the highlighting. Okay. Let's do it blue. Why? Because they did it blue. Bam. Bam. I'm not going to do that in the future, but the 4x is highlighted. Bam. They're like terms. So are the terms negative 2 and 7. All right, so the negative 2 and the 7 are like terms. I can't highlight that one. Okay, I'm going to continue on.
3x plus negative 2 plus 4x plus 7. First, apply the commutative property to get the like terms side by side. We apply this property to group the x terms and the numeric terms. 3x plus 4x plus negative 2 plus 7. Then use the associative property to group the terms. The sum of 3x plus 4x plus the sum of negative 2 plus 7. Finally, use the distributive property wherever required to add or subtract the like terms. The sum of 3 plus 4 times x plus the sum of negative 2 plus 7 equals 7x plus 5.
In this activity, you will create a linear equation to model a real-world situation. Then you will solve the equation to find the solution. Gavin likes biking. He never misses a chance to go for a ride when the weather is nice. This week, his goal is to bike about 65 total miles over 4 days. Remember in health class about setting realistic goals and being flexible? Each day he wants to ride 1.5 times as far as he rode the day before. How far should he ride on each of the 4 days to reach his goal? So on day 1, he wants to ride a amount, and then on the next day, he wants to ride 1.5 times that amount, and then day 1 and 2 times 1.5, and so on. So question 1. To solve this problem, first you need to write the expressions for the distance Gavin needs to bike each day. Then relate these expressions to create an equation that represents Gavin's situation. So just like before, we need to make 2 expressions and then make them into an equation. If x is the number of miles Gavin bikes on the first day, so remember we're using x as a variable. We're not using x as a multiplication symbol. If we need to use multiplication, we will put the variable next to the number, so x multiplied by 7, or a number in front, so 3x plus 2, for example. Okay, the multiplication is implied here, or the other way we can do it is parentheses and do, like, let's say a 3 out here. This would use the distributive property, 3 times x, and then 3 times 2. So that would equal 3x plus 6. Okay. And I'm just showing you that because I know that even at high school level, we forget that the x is not multiplication. So that's why I just showed you that. I know that's making the video longer, but I was trying to help. So if x equals the number of miles that he goes per day, on the first day, write an expression for the distance he should bike on each of the following 3 days. On each day, he wants to ride 1.5 times as far as he rode the day before. So on day 1, he rides X amount of miles. On the second day, he rides 1.5 times X. The third day is 1.5 times day 2, which is 1.5 times x. 1.5 times 1.5 equals 2.25x. 1.5 times 1.5 equals 2.25. Okay, I straighten these out so that way your 1.5x, 1.5x, and 2.25x line up just a little bit better. So we can see that these equal this, and so that's there. On day 4, it is 1.5 times the 2.25x from day 3 equals 3.375. 1.5 times 2.25 equals 3.375. Bam. Since the goal and the total distance he should bike over the 4 days must equal 65, the total mileage needs to be 65 miles. So we take x, the first day, plus 1.5x for day 2, 2.25x for day 3, and 3.375x for day 4, and clean that up a little bit. And what that gives us is the equation. So we've taken the expressions, expression for day 1, x, expression for day 2, 1.5x, expression for day 3, 1.5x times 1.5x, expression for day 4, 1.5x multiplied by 2.25x. So we're just taking what that expression equals. So that's an expression, that's an expression, that's an expression, and putting them where they go. And I can make those pink for us because that's fun. Bam. Okay. All right. We don't want any signs getting in that were making us all confused. All right. So now all we have to do is simplify that and solve it. Okay. Whew. Simplify and solve. To simplify, we're going to add all of these together. So on our calculator, we have 1x plus 1.5x plus 2.25x plus 3.375x equals 8.125x. So 65 equals 8.125 x. I think that's going to be pink, but that's okay. So now, remember, we want to get the variable on one side and the numbers on the other side. So here's what we got to do. All right, and then if you remember, in order to get rid of the numbers in front of the variable, we have to undo it. So 8.125 multiplied by x, to undo that, we need to divide this number out. So I would essentially be dividing, here, let's even use a pink here, divided by 8.125. And then we should have 65 divided by 8.125. equals x. All right, just for giggles. So we got our 8.125 divided by 8.125. We bring that over onto this side. We then are left with an equation that if we kept it lined up a little bit, I'm going to mess it all up, ain't I? So this equal sign and that equal sign should be right above each other. But 65 divided by 8.125 equals x. If I do that math on the calculator, 65 divided by 8.125 equals 8. So 8 equals x. What does that mean? That means 8 miles on the first day. And we can then work to check that. That's probably what some of these are going to be doing. So let me see if I did all the work on part 1. But so the first part A, says if x is the number of miles Gavin bikes on the first day, write an expression for the distance he should bike on each of the following 3 days. So right here is that expression. That's all I had to do on part A. So then part B says write an expression representing the total distance he should bike over the 4 days in terms of how far he bikes on the first day, x. Do not combine like terms. So that was this step, I think. That should go. Okay, that's close. Yep. The expression Gavin distance. The expression for distance Gavin should ride each of the following 3 days is 1.5x, 2.25x, and 3.35x. That's what we did up here. Bam. So now write an expression, the total distance he should bike over the 4 days in terms of how far he bikes on the first day. I believe that's it. Yep. So the expression representing the total distance of 4 days is, oh, I'm sorry. It's just that. Okay. Because he's going 65 miles, what equation can we use? 65 equals x plus 1.5x plus 2.25x plus 3.35x. We did all of that up here. We did all of that. Unfortunately, because for me, it's easier to work step by step by step by step, they broke it down. Part A is to here. Part B was to here. Part C adds the 65 part on there. Which terms in the equation you found in part C are like terms involving x? These are all the like terms involving x. Now, because the whole point of this is adding like terms, now that you have the equations, solve it to find the number of miles Gavin should ride on each of the 4 days. We did that, and it is 8 miles. Oh, sorry. To solve to find the number of miles Gavin should ride on each of the 4 days. Okay, so 8 miles on day 1. Day 1 equals 8 miles. So if that's day 1 is 8 miles, then 1.5x day 2 equals 1.5 times x, so 8. 1.5 times 8 equals 12 miles, so equals 12 miles. Oops. Sorry, guys and gals. Day 3. What'd I do? I think I zoomed in. Okay. Day 3 equals 2.5x, which, if we then put 8 there, 2.25 multiplied by 8 equals 18. And finally, day 4 equals 3.375 multiplied by 8 equals 3.375 times 8 equals 27. Now, this is fairly realistic. In my older, not very good shape, I could ride 8 miles, and then the next day ride 12 miles, and then the next day ride 18, and the next day ride 27. Now, here's the check. We got to solve for x. We already did that. I don't understand. We did that. It's 8. Okay. Use the expression from part A of question 1 to find the number of miles Gavin should ride on each of the 4 days. I'm pretty sure we just did that. Copy. Maybe I'm confused. I don't know. So, there you go. Now, add the number of miles you found for each of those 4 days. Does it come out to 65? That's our check. All right. Now, I don't know about you, but I cheat. I'm going to do the calculator business. But like I said, I kind of cheat a little bit. Oops. I meant to clear that out, not close it out. Hey, Siri, what is 8 plus 12 plus 18 plus 27?
8 plus 12 plus 18 plus 27 is 65.
Whoop, yeah. So, there's more than one way to do this type of thing. So it does equal 65. We did it correctly. We checked it. Submit. 65. Yeah. All right. Nice. What does your result in part D mean? So what does this result mean? It means that we did the math correctly. We solved for x correctly. I don't know if that's what it's going to say when I hit submit, but the result from part D confirms. That means we did it correctly. Confirms is positive. Gavin should cover on each day adds up to 65 miles. So the number of miles Gavin should ride each day of the 4 days is 8, 12, 18, 27 is correct. We do our self-evaluation. The hardest part of this was keeping everything in order. We hit submit. Awesome. Somewhere I didn't hit submit, and it won't let me move on until I do. Make sure you check yourself before you wreck yourself. And bam. All right.
Solving the problem about how far Gavin should ride each day to meet his goal required combining like terms and then solving. The table shows these distances and Gavin's goal. It's good practice to recheck answers whenever possible to make sure the calculations were done correctly. In the lesson activity, adding up the miles Gavin rode each day to determine whether they totaled 65 miles was one way to check the answer.
Bam. This is really not... Okay, so I highlighted those. All right. All right. Okay, one way of checking the answer and making sure that the calculations were done correctly is by adding up the miles. Oh man, this is so frustrating. I'm trying to make this all visible and clear, and it's just becoming crazy. So, is by adding up those miles and seeing if they totaled 65. If the total was 65. Awesome. We did that. So for this first one, and I'm not going to try to use all this wonderful blank space. I'm going to try to solve these as quickly as possible. I look at the like terms. I need to get minus 5 over 2x on this side of the equation. So I'm going to subtract 5 over 2x and get it onto this side. So I'm left with minus 4 on this side, just this minus 4. Well, I'm going to add 4 from this side, cancels that out. Add 4 to this side. Negative 4 plus 4 is 0. So now I have 0 on this side. So no matter what I do over here, x, or fractions of x, is going to equal 0. So, done. For this one, we're going to look at combining the like terms. So I'm going to add the 1.7b onto this side, which is going to make it 4.9b. And then I'm going to subtract the 10 from this side over here, minus 10. Well, I've already got a negative number, so now it's going to be even more negative. It's going to be negative 14.7. Then I apply the distributive property, and I'm going to get the, what was it, 4.9. I'm going to divide that, divide by 4.9, and 14.7, 14.7 divide by, what is it, divide by 4.9, I think it was, equals 3. It's a negative 3. I know that because it was a negative 14.7 minus 10 to get rid of it. So minus 10. So that's going to be negative 14.7. So I know the answer is negative 3. Whew. All right. On this one, it's going to be, let's see here. I'm going to add the 6.7 onto this side. Or sorry, I'm going to subtract the 6.75 from this side, subtract it from over here. I'm going to minus the y from here and add it over here. And then I'm going to, so that should leave me with 6.6y. Oh, So when I subtract this y from this y, I'm left with 6.6y equals negative 13.2 and 6 point, I gotta divide the 6.65 or 6.66 to get rid of it. And what I say, that was negative 13.2 negative divided by 6.6. 6.6 equals negative 2. That's that answer. Bada bing, bada boom. The last one's going to equal 5. How do I know? Because it's the last one there. But just in case, let's look at it. We're going to put 2c minus 7c. 2 minus 7 is negative 5. Negative 5c. I'm going to get rid of this 8. Minus 8 minus 17 minus 8. So 17 minus, minus 17 subtract 8 equals negative 25. What did I say this was? Negative 5. So I got to divide negative 25 divided by 5. That is negative equals 5. Bam. Submit. And we got it all correct. Awesome. How do I push the play button?
We can use linear equations to model many real-world situations. In this lesson, for example, we wrote and solved linear equations to find the heights of 3 friends, to determine the number of coins each of 3 boys had, and to find the number of miles Gavin had to bike each day to reach his goal. To solve a linear equation, we need to get a variable term alone on one side of the equal sign and a numerical term alone on the other side. The first step is to use opposite operations to transform the equation. Performing the same operation on both sides of the equal sign keeps the transformed equation equivalent to the original equation. Once the variable terms and numerical terms are on opposite sides of the equation, we can apply the associative and commutative properties to group like terms. The associative property lets us freely group the terms on each side of the equation. The commutative property lets us reorganize terms into like terms. The distributive property is helpful for combining like terms. Combining like terms means adding or subtracting the terms with the same variable and the terms with no variable. Wherever possible, it's a good idea to recheck answers. Substitute the answer back into the equation to check whether it holds true. That will confirm the calculations are correct.
Whew, congratulations, we've completed the tutorial solving linear equations. If you're still hanging on after all of that, that was a wild ride. Note to self, use scratch paper, keep things straight and in order, and when in doubt, read the directions again and go step by step. Have a great day, and thank you for surviving another math lesson. Solving linear equations tutorial.